Hey, hello everyone. I'm Daniel, and today I'm talking to you about code quality, or bad code, or how they told me in Polish, kod parszywy. I'm going to be covering a more data sciencey aspect, because usually people talk about code quality when it comes to normal software engineers. As Magdalena mentioned, I just flew in from New York a few hours ago in this morning because I wanted to come, so I had to book an earlier flight to get here, so I'm really excited to start. Też mówię po polsku trochę, ale na taki temat nie dam rady, to będzie po angielsku. Okay, so first, what's my motivation for talking about that? And the biggest one is that I worked with like half a dozen of American companies, and a lot of them have, mildly put it, very, very bad code for data stuff. Whenever I join, I have to touch someone's code, and it just doesn't work. It's like I have to spend hours to debug, to understand what that person was trying to write. Sometimes it doesn't even have Git, just so many issues with it. And the same organizations also have when I go to repo for their web app or their mobile app, they have pretty good code there. So there's this strange gap between normal software engineering and data engineering or data science. So I'm just here to raise awareness that code quality is relevant everywhere. So I'll start with why you guys should care about code quality, because it's usually not the first thing on people's mind when they write code. And we'll start with for those who work in a team. So if you're a data scientist or a data engineer, then why do you care? And that's the most obvious one. You work with people, so you want to be able to delegate your work to others, right? You want to, if you wrote some function that processes some data pipeline 5 years ago, you don't want to be the one to have to maintain it all the time you're working at that company. You want someone else to take it over from you so you can do something else. You want to delegate. Giving accurate estimates. When you're working with a business, your team lead would ask you how long it's going to take, how long implementing something's going to take, how long fixing something's going to take. And if you haven't touched that piece of something for a few years, you'll probably not remember what it is, and you'll just give a wrong estimate because you'll think, oh, I know how it works, and then you just realize you don't know how it works. And, well, generally, being seen as a professional, it's a good practice when people see your good code that you spent not hours, but you spent extra few minutes to write a comment, and you're literally the only person in the organization who does that, and people would really appreciate that. So that's for as an individual in a team. If you're a manager, doing code quality, making code pretty seems like a waste of time, right? Well, of course, there's the same argument that you don't want to depend, or your organization to depend on one only person, that the only person who knows how the whole thing works, because, well, you might have to pay them more, and your organization might break if that person leaves. Obviously. And the other thing is, even though it seems wasteful to have people spend extra half an hour on organizing their code, it feels like, well, if they can do it faster, why not do it faster? Well, because it is actually more expensive in the long term. Because when people, while they know how they designed their thing that they designed, while they have it in their mind, if they don't put it down anywhere, they don't document, they don't write comments, and someone has to modify it, which inevitably happens all the time, that's equivalent to taking a debt, because you didn't spend the time now while you remembered, so you have to spend the time later to remember or to figure out how it works. And that's what it is called a technical debt. You're taking a debt against your future self to get the feature faster at the cost of your future self. Well, and obviously more reliable plans, because you do want to predict things to happen, and you want your code to be good enough that people can actually predict it. Well, and last but not least is, if you're a solo developer, maybe you're doing your own projects, you can write shitty code, that's probably fine. But a big assumption, and you probably, if you've written any code and have come back to it after some time, you probably won't remember shit from it. Or, well, you'll remember some from it, but, it's good to leave at least some notes for yourself, because when you come back and it's you have no idea what's happening, you would appreciate your past self as well. Anyway, Let's talk about first a little bit of theory. From software engineering, you probably heard about this trade-off in this form, in another form. This trade-off is between three fundamental factors that influence software development. So that's speed of production, how fast you were given a task, how fast can you implement it, obviously, the first one. Second one, resilience, how well the code works, does it break, does it need to be fixed, how flexible it is, how much you can achieve with it. And the third one is maintainability, which can also imply how easy the code is to read, how easy for other people to maintain the code, etc. So the trade-off is that you can't really have all of them. You have to pick one or two or prioritize some of them, because you can have a scrappy code that works very well, or that doesn't work very well. You got it out really fast, but it doesn't work really well, and no one knows how to maintain it. So it works now, but it's going to break. Or you can have an over-engineered, over-tested code that took you eternity to write. That also is hard to maintain, because even though it's over-engineered, it's not documented. There are different combinations for it. And these two being maximized is the most common one at the cost of understandability, and we're all paying the price. Let's talk about an example. So this is going to be an example from one of the companies I worked with. I tried to anonymize it, so you don't know which company it is, hopefully. Okay, well, I'll give you a minute to look through this piece of Python code. It's data engineering. It's a Kafka producer, I think. So I'll just give you a minute to look through it, and then I'll ask you guys for what you think is wrong, and we'll compile a list of what could be improved about this code. So just take a minute to look through. Well, I'll probably start collecting guesses. Anyone wants to point out what is off about it? What can be improved?
Quite a lot.
Let's go into detail. Which one?
If len message batch cannot equal to 0.
Oops, that was sorry, that was a spoiler. Wrong button. This one.
Global, of course. Yeah, this one.
Yep. So you're saying it doesn't have to be there? Yeah, because otherwise it's pass, right? So we just extra indentation that doesn't have to be there. Yeah.
The globals. Global.
Yeah. Global variables. You can see it's a self. So it's a function in a class. So there's a class. I don't think you need global variables when you have a class, unless it's some special case. But yeah, that's a good point.
It's not C++, so you don't have to.
Yeah, exactly.
Moreover, there's two loops, but there can be only one instead of creating arrays and
Mm-hmm. Yeah, so we're iterating through this like dictionary once, adding it to a list, and then iterating through this list. Yeah, it can be done once. It's like an efficiency thing.
What is the underline?
What is?
This one is underlined because
it's also a strong assumption on type of the key.
Mm-hmm.
It should be compared with batch limit.
Yeah.
Yeah.
Well, exactly. That's like, what is this key? Why are we comparing it? Like batch limit, probably an integer, right?
Yeah.
Like you can assume why are we comparing a key? Key sounds like it would be like a string or something. Yeah.
The batch size should be, let's say, consider the length of message batch.
Mm-hmm.
Since we are adding there on it.
Okay. Yeah, that's good. Anything else? Anyone can?
The old code is commented.
Oh. Yep.
Any comments was very long.
Yep. That's the only comment we have here is just the commented out statement from before. Yep.
And spaces after commas.
Yeah.
And those spaces Around Marcus also.
Honestly, I feel like that's the least problem here, but yeah.
Error handling.
Which one?
Error handling.
Oh yeah, yeah. If there's an error, just pretend it didn't happen. Just continue. Great practices here.
It solves all the problems.
Yeah. Well, I guess we can finish here. There's a lot more. Like here, the one that I listed. So like we mentioned, well, obviously no comments. Nesting that you mentioned for this one. This one also doesn't need to be here. Like it can be a simple if statement in the beginning, and instead we're adding an extra layer of indentation in the whole code for no reason. Global variables that probably also don't need to be there. Variable names like key is the only one that was unclear. Comment code, except for loop. Yeah. Anyway, well now I'll give you a harder task. See what's good about this code. Give it a compliment. Besides the fact that it probably does a job, which you also don't know. So that's fair. Well, you know, comparing to a baseline, you don't know how short this could be, but yeah, it fits on the screen, so it's.
It looks like there are no syntax errors.
Yeah, it's a pretty low bar, but yeah, that's true.
Probably working.
It's
Probably working.
Yeah, it's. I hope so. I took it from a repo.
I would say that there was probably an attempt to split it into separate functions. As we can see, there's a run. It's not in a.
Oh.
You know that the whole main part of our function.
Yeah, that's true. Like, oops. Well, that was a spoiler again. Oh, dang it. Yeah, like we have the batch limit here, we have some other things. They're not defined here, they're defined elsewhere, so there are other functions. It's good. Well, the only one I pointed out is that variable names are fine. You can guess what like an offset is if you have like some Kafka background. You can get what a batch limit size. Well, okay, well, not a lot of good things to say about this code anyway. So I took my little time to refactor it with the focus on not doing it for too long time, and this is a very, very basic thing, what you can do with a code like that. So I didn't remove the globals because I didn't want to care about that. But this if statement that in the beginning we had, the if statement that just indents the whole function can be a thing in the beginning that returns and we don't have any indent. Like obviously, why didn't they do it? Whatever. Then the rest of the function, this is the run, so this is our new run, is 2 steps: get messages within current batch and send messages to Kafka. 2 more easy to understand high-level steps. Here we have, well, I don't know if that was too great, but at least replacing key with message ID, because apparently in Kafka, a key in a dictionary is the ID, and well, this is largely unchanged, except now we have a log. So, and I also wrote I wrote with a little example. So I don't know, you can, yeah, well, just the good practice. It's adding an example of what that kind of data looks like. You know that the key is an integer, and you're assuming that the key is an integer because it probably comes from somewhere. And then if you have a specific example of batch limit is 105, so you're not going to go behind 105. Size is 5, so we're going to take 5 things from 101 to 105. That look like this. I mean, it's a very, very simple example, but I hope so, at least, that looking at this, or like looking at this even without the docstring and with the docstring, you would understand it better than whatever this monstrosity is. I didn't. Well, I don't know if it was working to begin with. So, yeah, it's mostly like an illustration of things that we kind of all know that should be done, that it's nice to read code like that more than before. I'm not saying I'm a professional code designer or anything. Anyway, let's move on to another example. So this one is a function from a more data science-y context. I'll give you more context for where this function is used. It's very short. That company has a customer platform, and whenever they open a website, they load this annual EP forecast value. And it's I'm not going to tell you what EP is, doesn't really matter. Every customer opens a dashboard, and this function runs to give them an estimate for how much EP there's going to be for the next year, from today until a year from now. So I'm going to also ask you to criticize it, look through it for whatever time, and you can just yell out if you think something, you see something's wrong. Yep. Mm-hmm. Anything else? Mm-hmm. Yeah. Yep. Well, technically there is this function that it's using, so it's it's I guess a simplification, because this function technically gives a range, I guess. So this is not the biggest concern here. But yeah, it would be still nice to have a yearly forecast from a date rather than from today. Yeah, that's also a good point. There is one more thing. Well, obviously the 6 unexplained, we can see that it's probably a pandas data frame. It's probably a 6th column of the pandas data frame that probably has a name, and I probably don't know why that person didn't write the name there and just put a 6 there. But besides that, I'm going to tell you there is a logical error here, because whoever committed this, there was no pull request. The person just committed it to master because that was easier, and something happened later.
Probably data line where he or she tried to use the datetime. Yeah, datetime delta date delta or something like that should be used here, because the line before we use the datetime as object. Or maybe not. Okay.
I believe that the mistake that is here is when we're thinking about February 29th.
Yep, because the point is, this code was written early 2020. And you know what happened a bit later, a few months into 2020? Was February 29, of course. So when February 29 hit, the code broke, and apparently there was no check for this code to possibly break, so the whole website went down for a day.
It's not a bug, it's a feature.
Well, I guess it was a COVID precursor or something. Okay, let's talk about Git. Raise your hand, how many of you have committed something to Git? Just great. Almost everyone. How many of you have reviewed a pull request? Basically the same. How many of you force pushed something to master by accident? That's also me. Oh. Well, yeah. We all have excuses. Anyway, so as I've learned, data engineers do use Git more or less. It's a thing, because data engineers, you still write scripts, you still make a program. Data scientists, they usually just do their crazy stuff in their notebook, take out the model file, and either give it to someone or just literally SFTP it on a server and have it run. I've seen that happen, and I don't really understand why that is, because Git is actually can be used for data science too. Even though when you think about it, Git is for version control of software, so you have resilience. Let me get maybe someone can brainstorm how can Git be used for data science? What is something that is data sciencey that Git can help us with? Just any wild guess.
Data version controls?
Yeah. So, yeah, anything. What else could we use Git for?
Data samples.
It's actually an interesting one. I didn't think of that. Data samples.
Modification we could pull their data samples.
Okay. I didn't write that one, but yeah, okay.
Also for model reproducibility, like we can check if it's platform dependent.
Yeah, actually, GitHub CI/CD. Yeah, it's pretty helpful.
For databases, for example.
Yeah, it's kind of harder with Git because you can't really. Well, yeah, I haven't written as many of those what they suggested. The one I have in mind is tracking the progress, obviously version control, and knowledge base, storing the knowledge of why things happen, when they happened, what was the intent for this to happen, and it's pretty cool. There are a few places where you can store information in Git, even though when you think of Git, you don't think of information, but Git is also information. The most obvious place is in commit messages, which a lot of people do that. You write a commit message that you updated your something file and then whatever. And that's very frustrating when you're trying to, you look at a file, you look, there's some weird change happened, you even find the commit where it happened with git blame, and then it says that. So better commit messages for data science can be something like this. You're committing a notebook, you change the parameter because you found that something is wrong. You can put that in a comment, you can put it somewhere else. You have to, but it's very good practice to put it at least somewhere so people who are coming there to retrain your model in the future, so they have an idea why you changed the value of alpha or something. And git commits is the very first obvious place to put it. Someone had a comment? I was here. Okay, maybe not. The other one is pull requests, which is also a really good source of knowledge, because when you're working on a bunch of things, you can have you're retraining a model for another release because you want to improve in accuracy or something. In a pull request, when you're making a pull request and it hopefully gets reviewed, you will write down I changed this value because that, I will change this because that. You're also listing your progress, because you do want to communicate this to people, because if someone comes back to it, you do want them to know why change has been made. And there are these other aspects that we mentioned about that, obviously more reproducible the code is, whereas when it's just a notebook somewhere, CI/CD for auto testing or platform dependency, and code reviews that tie nicely with pull requests. And I want to touch more on code reviews, because normally when people do code reviews, they're reviewing each other's architecture, each other's how well the code is written. But I feel for data science, the code review should be something more like a peer review, because what you're producing is more likely you do some data cleaning, you do some transformations, and you produce a model for some reason. You probably played around with parameters and stuff, and the goal of a peer review is just to get another brain to look at what you produced. It can be also looking at code quality. It can be about assessing if what you produced is understandable, but it's also about looking at your methodology. Does it look good to another person on your team who knows something about data science, that you're doing it this way or that way? And that's pretty important, to have knowledge transfer. At least if you don't leave comments, at least leave it in someone else's head. So there's two heads remembering it than one. I'm going to go to more practical little tips and tricks that you can implement as a developer data person in your practice. And these are the least time-consuming ones. So something that you can do on the go, not think about it too much. You'll have to think about it, but not too much. First one is just write down little small things that you come up with. So you're I don't know, you were listening to Michal's presentation and you figured out, oh, well, float 8 is kind of too small, I lose too much accuracy. Float 16 is kind of good balance. Write it down, put a comment, put it in a git commit at least, put it in a pull request somewhere, so that the person who's coming after you next doesn't have to go through the whole process again. So yeah, documentation, comments, commits, pull requests, variable names is a good one. A lot of things can be stored in variable names. If you have like function names to not explain that here we're doing a call. You just put it in a function, call the function what you want it to be. Yeah, so writing down small insights is the first one. And again, get others to review it. Doesn't have to be a full peer review, code review where you sit down in a meeting and you walk for an hour with each other. You just make a pull request, send it to another person. They leave a comment or two on your things. You asynchronously talk to each other, and that's at least there is some record of you talking to other people. And there are options that are more time consuming, but are also rewarding. But don't get me wrong, if you do these, that's already 80% better than probably most American companies. Anyway, the more time consuming is you can reorganize the code. It's a bit more painful. Like if you have a huge function, the one we just saw wasn't a typical spaghetti function, but there are these, like, you've probably seen them, like very long function that has a bunch of things going on, a lot of if statements. Just split it up. If there are a few if statements, put it in few different functions, Just reorganizing the functions, putting high-level code at the top. That's my preference too. So people, when open the file, they see the code at the top and know what's happening. Reward a function, whatever makes sense to you. The goal is just to preserve what you know about the code and put it inside of comments, names, organization, etc. And yeah, write things down a lot. Do examples. Examples is my very, very best advice for especially data things. When you look at a bunch of functions that do some transformations, you're like you can explain people that it's doing like a mean squared sigma something, but you can also just give an example of like 3 numbers and people are going to understand it much better than a formula in most cases. Well, and with these, I'm going to leave you for today. Thank you for your attention, and I'm open to questions. If there are questions, of course.
Okay, any first question?
Go ahead.
What about unit tests?
I didn't touch on that. It is important. If we go back to here, unit test is more like this part. So if you want your code to work, be reliable and stuff, unit tests are important, and you can do them in everywhere. It's just that I was mostly talking about like code quality from the perspective of readability, but I'm not saying don't do unit tests. Unit tests are great, and if there were unit tests, this thing would not have happened.
Good for the document, right? Because you write down how you expect function to work, and then you can work
Mm-hmm.
that to the
Yeah, test-driven development. You can first write the test. A lot of people don't like doing that because it's a lot of hassle, especially data scientists who are just used to, knowing from myself, you just get things done, and then if someone asks you to write a test, you just retrofit it. So, it's a balance, find whatever works for you. And I feel like maintainability and readability of the code long-term is more important than having it tested now, because if it breaks, it will break even with unit tests, but if it breaks without unit tests, there will be someone to fix it, at least. Any more questions? I don't know, concerns, things? Go ahead.
Maybe just to advise, this would be first one. You can also consider using something like pre-commit hooks. So whenever someone commits, he has to already get rid of extra spaces or no spaces after commas and so on. Also, it's worth mentioning that there are tools that evaluate the code on the basis of code source. Like for example, SonarCube is one of them, and it gives a percentage score, for example. Different things of how rapid it is.
Yeah, that's the IDE telling you that something is wrong. So, yeah, tools is like time consuming. You do have to figure out. There are these tools. There are like these like ChatGPT based tools that like on every commit it's going to ask ChatGPT what's like off, where it's not readable, what you didn't explain, it's going to tell you. It is time consuming. So
but I'm talking more about tools like
like a linter.
Standard just like listers, like,
Uh-huh.
I don't know how to
Yeah. Mm-hmm.
That's something that can you can set up in a second.
Yeah, things that like if you have a 200 character line, it's just gonna at least split it out. It's already better. Yeah, just use your IDE suggestion. Your IDE is smart, sometimes smarter than the developer. Any more?
About this more time consuming idea, so maybe this is a general question for the audience. So maybe the person what you are basically using, because as you're working on linter, stuff like that, I think that in our basic pipeline, like the template, that we have labels, we have like 5 basic steps, but in the most complex it goes up to 13, right? So with the docs, ask the GPT for stuff like that. So it's pretty interesting. What are your experiments with that?
Yeah. Yeah, I mean, I can tell from my end, we have very like where I worked. I'm basically the only person on the team who does that. So whatever I do is for myself. So it's like, lower quantity. But we have one GitHub action item with a GitHub action check that checks for things like this. Can't boast anymore. Anyone else can like anything for inspiration? Anyone else uses?
What do you think about like require more approvals for in code review than one? For example, you need like 2 approvals. So what's your experience?
My experience is that one is kind of too many. Like, well, enforcing one is too many. It is good to have other people look at it, but it's also good for a developer, for a data engineer to not be halted. Like it's, they're the only one working right now. Their teammate is like out of office and they can't merge their own code to fix something that is breaking now. It's good to like give people freedom. If they really have to commit something, fix little thing, they don't have to ask someone else to click a button, because that's also meaningless. You want people to out of their goodwill go and ask other people for feedback. And at 2 people, I feel like I feel like up to every company to decide. For small commits you're making a typo change and then 2 people have to.
Like 2 weeks of work
Yeah.
I think it's also about the criticality of the system, because if something is, if the system is not critical to the company, like that,
Yeah.
it will break a whole bank.
If you work with juniors or with seniors, probably also.
Yeah.
And what do you think about seniors sending the code to juniors for review, for learning?
I've never seen that. It's always been the other way.
Yeah.
Huh. Have you had experience with that? Does it?
I was experimenting with
And how did that go?
it was cool. There were times that I really noticed something that I
Was it more insightful than giving it to ChatGPT?
It was before.
Okay. Yeah, I feel like ChatGPT is going to replace a lot of juniors.
Basically, ChatGPT is nice and everything, but in many companies we are not allowed to do this because of privacy. Even though we have private, we have our own instances of GPT in Azure, in our subscription. Also, let's call it private, but still clients do not allow us to use them. We cannot have files for them.
Yeah, it is strange.
Especially because, for instance, writing a lot of comments. So basically, when we are writing those things, so GPT is great for that, because we just write those commas, 3 marks, and that document is generated for you. It saves a lot of time.
But comments from GPTs couldn't have the good quality, because I need that situation when you see that this comment is written by ChatGPT is a lot of lanie code, nie? A lot of
can find out something about your cultural comments, like something.
Yeah, it's the same thing, right, with like all of the AI tools. We can outsource them some things, but we always have to review there because we can't trust them. We can't trust them to write the code for us. We can't trust them to write documentation for us. Yeah, it is useful to have ChatGPT write a draft for you or help ChatGPT figure out an old code that you never touched. And then you still need to try and figure out if ChatGPT is right because it's always wrong, often wrong, not always. I think I'll finish here. So thank you guys for listening, and I hope you got inspired at least to leave some comments. What? Oh, right. And add me on LinkedIn.
Okay. Yeah.
Thank you.